This conference will now be recorded.
So, very good evening, students. Today, we'll be continuing discussion on amplitude modulation of signals in the chapter communication systems. So, I'll just recap the first slide. I'll recap a little bit what we have learned about amplitude modulation. Actually, amplitude modulation is the process. So, it is the process in which the amplitude of the high frequency carrier in which the amplitude of the high frequency carrier wave changes in accordance with the instantaneous value of the modulating signal. Okay, modulating signal. I'll explain what I have written here. So first of all, what is modulation? Actually, modulation is required for transmitting signal, low frequency signal from one place to another, because we know there is something called loss of strength, loss of strength of signal. So if you have a low frequency signal, basically the audio signals are low frequency signals. So when you transmit one audio signal from one place to another, which is a far away place, so the signal will actually die away, okay? Or at the receiver end, the signal will be lost, okay? Proper signal will not be received by the receiver end. So to transmit such low frequency signals, modulation is required. What is modulation? Modulation is the process in which the low frequency signal will be actually, you can say, enveloped or guided by a carrier wave, and carrier wave has larger or higher frequency. Suppose in this case this is the modulating signal or message signal, okay, which has a very less frequency, like a smaller frequency. So this signal has to be transmitted from one place to another but without any loss of this signal, if we want to transmit, then we have to, what we have to do is the modulation. You can see that this is the modulated part. So this is modulated signal. This is the original signal. This is the carrier signal which will carry the signal so that there will be no harm to this original signal or no loss of the original signal. Sometime, like, see, if we send glass wires from one place to another place in transport, what do? We wrap it very nicely and then write also that this is glassware, something like that, or fragile items, kind of those. Okay, so that things will go safe. Similarly here, see, the carrier wave is kind of envelope. It will act kind of envelope to the original signal. Okay, it will just cover the original signal and carry safely without any loss. Excuse me. So you can see in this modulation process, what happens actually in the modulation process, the carrier wave which has a larger frequency will be modified in magnitude or amplitude. In case of amplitude modulation, the amplitude of the amplitude of the carrier signal will be modified according to the modulating or the message signal. You can see that this is the message signal and this is the original, this is the carrier wave. This is the carrier wave which is actually which is modified by the original signal. This is the original signal. Okay, original signal, right? So this is the original signal and this is the carrier wave, and amplitude of the carrier wave changes according to the original signal or the message signal. Okay, this is what happens in case of amplitude modulation. Okay, now further what we had learned that modulation can happen to the different degree of modulation can happen. Okay, like, see, I can say that this amplitude can change by 50%, 100%, or more than that. Okay, so the different degree of this modulation happens, and that is done according to the requirement. So this different degree of modulation actually is characterized by a factor called percentage modulation or modulation factor, and that modulation factor is denoted by mu, how much the carrier wave is modulated according to the original signal. Okay, so this modulation factor or percentage modulation is given by mu is equal to a max minus a mean. I'll tell you what is max and mean, divided by a max plus a mean. So what is a max? A max and a mean are actually the amplitude of the modulated signal. You look, this is the modulated signal. It has maximum here. This is the maximum amplitude. Look, and what is the minimum? Here is the minimum amplitude. Minimum is not necessarily zero here. Minimum modulated signal is not zero. You can see that this is the minimum part, and this is the maximum amplitude of the modulated signal. So the factor is denoted by mu, and it can be written as a max, that means this value minus this value divided by this maximum plus minimum value. So this is, now if you multiply with 100, then it will be called as percentage modulation. Okay, this is important to know, and sometimes this mu is denoted by am by ac. What is am? This is the modulating or the message signal amplitude of message signal or message signal, and this is amplitude of carrier signal or carrier wave. Okay, so am by ac, we will be sometime using this expression also, sometime this expression. Okay, so this much we had discussed what is amplitude modulation and what is modulation factor, etc. we had discussed. Now today we'll go further in detail of this amplitude modulation. First of all, what we'll do, we'll derive an expression. We'll derive an expression for the amplitude modulated wave. See, this is the modulated wave, right? This is the modulated wave. We'll derive an expression for the amplitude modulated wave. Okay. That means we are going to derive the resultant of the amplitude modulated wave. Okay, so let us say the modulating signal or the message signal is denoted by mt. I'm just writing here, mt is equal to am sine omega m into t. So where you know this mt, this is the instantaneous value of modulating voltage or message signal, instantaneous value, just like your other waves, how we denote instantaneous value of modulating signal. Okay, and what is am? Amplitude of modulating signal. And similarly, this omega m is actually 2 pi fm, or I can write fm is equal to omega m by 2 pi, which is the frequency of modulating signal. Okay, so these are like this is kind of a wave, and see, this is amplitude, this is frequency of the wave, and this is instantaneous value. So as usual, like these are having usual meaning. This is the message or modulating signal. I can write carrier signal CT, similarly AC sine of omega C and T. Okay, carrier signal. All right. Now what we'll do, we know the amplitude of the carrier wave changes according to the frequency of modulating wave, right? That is what we know. Amplitude of the carrier wave varies at the frequency of modulating wave. So the modulated wave amplitude of the amplitude, see what we know, this amplitude of this of the like modulating signal. See, the amplitude of the modulating signal will vary with the frequency of the modulating wave. So that's why what we can write, okay, what we can write is that the amplitude of the, okay, let me write amplitude. So since amplitude of the modulating modulated, that means the resultant modulated modulated signal will vary with the frequency omega m. So what we can write, we can write the amplitude of the modulated wave can be written as A is equal to AC plus some factor or modulating factor into AM. This is what we can write. Okay, what we can write, we can write the amplitude of the carrier wave plus, I'm sorry, this is no, this is just sum over that. Okay, AM plus AC. Okay, AC plus AM. So what we know, AM, just a minute, this is this should be AC plus MT. Okay, MT, we should write like this, MT, this one itself. So we can write here AC plus AM okay, then actually it means that the amplitude is changing with the same frequency. Okay, now look, use this. Okay, this is what we have got now. Okay, let me give some animation to this, later we may need it. Okay, so let us do the simplification of this. So what we have got, amplitude of the modulated wave as AC plus, we'll make it to two parts. This is AM sine of omega m into t. Now, what we know about am? See, mu is equal to am by ac. This is what we know, right? So am can be expressed from this relation mu into ac. So this is what we can write here. In place of am, if we write ac, mu into ac sine of omega m t. Okay. Now let me erase this. Now look, if we take AC common, then we get 1 plus mu into sine omega m into t. Okay, this is what we get. Alright, now then we can write the instantaneous voltage of the amplitude modulated carrier wave. So the carrier wave is actually modified, right? So how we can write the carrier wave now? We can write the carrier wave after modulation. The amplitude will not be AC. It will not be AC. It will be A, what we have got here. So the modulated carrier wave, we can write modulated carrier wave. Okay. So this is A into sine omega c into t. What is A? A, we have got this one. We'll put it here. AC into 1 plus mu sine of omega m into t whole into sine omega c into t. Okay. If we record this space, we will use this. Okay. Now look, I can just write this as AC sine omega c into t. Then look, this part I'll write here mu by 2. Sorry, I'll just divide with 2 and multiply with 2. Mu by 2. Then we get 2 sine omega mt and sine of omega c into t. This I have done with an intention. Why? This I can use uh, like we can use trigonometric identity. This one 2 sine a. Okay, let me just write this itself, sine omega m and sine omega c into t. So this, if I say this is a and this is, okay, let me write 2 sine a sine b can be expressed in terms of addition. This is multiplication type, so you can make it to subtraction or addition type. So let see, this will be cos of a minus cos of b. Sorry, cos of a minus b, cos of a minus b minus cos of a plus b. Okay, so this is the identity we can use. Okay, cos of a minus b minus cos of a plus b. So this will be, so this term 2 sine omega m t and sine omega c t, this can be written as cos of omega m minus, sorry, let me write, because this frequency is more for carrier wave, let me keep this as anyway, cos of c minus cos of omega m minus cos of omega c plus omega m. Okay. Oh, there will be obviously t in each case. So this is what we can write over here. Look, I'll write here AC sine omega c into t, and this is mu by 2. Okay, and obviously there will be AC also here, AC into mu by t. Okay, AC here, and along with that this term will be cos of omega c minus omega m into t minus, okay, let me write separately. So this is plus, and another term is mu by 2 AC cos of omega c plus omega m into t. See, so what here we have got now three terms. We have got three terms. Okay. See that after modulation we have got three terms for the carrier wave. See, original carrier wave. Along with that, some wave which has amplitude just half into this is a half of c into mu. This factor, that means it is less than the original one. Okay, less than the original one, but and the frequency also is less than the original frequency omega c. And one we have got any of these two, they have same amplitude, but frequency is different. Frequency is much like this greater than this one. So what I am getting, actually I am getting in fact three signals out of two. Okay, after modulation what we are getting, we are actually getting three signals. Okay, so wave it is, see this, if you see, this is actually sum of different wave. Okay, let us see the first one. So this is the first one, AC sine. Let me erase this part so we can discuss that there. This is very interesting. See, after modulation we are getting three signals. Actually this is three different waves. We'll read what is the significance of that also. So the first wave is the original one, AC sine omega c into t. Okay, this is actually the original one, original carrier wave. If you recall, I have written it here. You can see that this is the original carrier wave. Okay, and it has frequency of the original wave, as you know, the frequency fc is equal to omega c by 2 pi, right? And amplitude AC. So these are two characterizing factors. Okay, now the second wave, you can see that is mu a by 2, and you have here, this is the amplitude and this you like, you can write, we can take the plus one first, omega c plus omega 1 into t. So this is the second signal, suppose second wave what we get here, and it has actually less amplitude than the original one, that you can figure out from here, but the frequency is more. Frequency is more. So see the frequency, uh, frequency fc plus fm. Okay, so this is what we get for the second wave, and amplitude is actually with this factor, this is much lesser than this, because mu is always less than 1, or at the most it can be 1. Okay, we'll discuss that also. And the third wave, which is this one, this one, so it has again the amplitude this much, then sine omega c minus omega 1, this has lesser frequency than even the original one. Okay, so frequency fc minus fm is equal to omega c minus omega m divided by 2 pi. So these are the three things we have got here. So clearly the process of modulation does not change the original carrier frequency, but it produces other two frequencies. One is fc plus fm, another one is fc minus fm. So what is happening after modulation? Actually, the carrier wave frequency is not changing. Okay, or the amplitude also doesn't change. Actually, it creates another wave which has lesser amplitude than the original carrier wave, and also it has, one of them has greater frequency than the original one or original carrier wave, like this one. Okay, original carrier wave, and the other wave has frequency lesser than the carrier wave. So the frequencies which are, so now I'll erase this part also for the discussion purpose. We'll use, so you can see the frequency which is greater than the original one, that is called upper side band, upper side frequency band, and the frequency which is lesser than the original wave or the original carrier wave, that particular frequency is called lower side band. Okay, so this fc plus fm, this is the greater frequency. Okay, this is called upper side band. Okay, this is called upper side band, and in short it is called USB. Okay, USB. So USB means this one. Okay, if I write USB in short, it is fc plus fm. Okay, now what is the name for this particular frequency? This has also a name. This is called LSB, that is lower side band. LSB, lower side band. I'm directly writing LSB, that is called lower side band. I'll spell it fc minus fm. So lower side band. Okay, so what you get after modulation? You get lower side band and upper side band. That means you are getting actually three different frequencies, as the carrier frequency is many times greater than the modulating frequency. So the sideband frequencies is close to the carrier frequency. Okay, look what does it mean. Okay, I'll just erase these things and let me bring the figure over here. Okay, is these are the frequencies as we had derived. So they have written in terms of angular frequency itself. And see, this is the frequency I'm writing here, fc. This is fc plus fm, and this is fc minus fm. Okay, so this is lsb, and then this is usb. Okay, and this is the original one. See, this frequency, this fm is actually the frequency of message signal, if you remember, or modulating signal, frequency of modulating signal. And we had already shown you that this frequency is much less than the carrier frequency, right? fc is actually much greater than fm. Therefore this usb and lsb, they are not very far from each other. They are not very far from this original one. Okay, this gap is very less. It is for the representation purpose, this gap is shown wider, but this gap is not very large. It is not very large. Okay, because this fc is much greater than fm. Suppose it is 100 and this may be 2. So 100 minus 2 will be 98, or 100 plus 2 will be 102. So this, see, and this is the 100, original one is 100. This is so you can like guess that this fc, lsb and usb, they are not far from each other. They are situating very near to each other. Okay, that is what it is. Now the difference between the usb and lsb will give you the bandwidth after amplitude modulation. See, I'll just take the difference. Let me write the difference of the highest and lowest frequencies present in the amplitude modulation wave. Difference between the the highest and lowest frequency present in the amplitude modulated wave is called the bandwidth. The bandwidth. width, bandwidth. So here there will be a d, width. Okay, bandwidth. So you can see what is bandwidth. We generally abbreviate this bandwidth by this. So this will be fc plus fm minus of fc minus fm. So you get 2 into fm. This is bandwidth. Okay, this is bandwidth. So 2 fm. Hence the bandwidth of an amplitude modulated wave is the twice of the frequency of modulating wave. You look this this is the fm. This is the frequency of the modulating of wave or message signal. Twice of that is actually bandwidth, twice of the frequency of modulating wave. Frequency of the modulating wave, that is 2 into FM. Okay, so this is one part of the derivation, and sorry, not one part, this is the full part of the derivation part. Now we'll try to see various type of waveform of a carrier wave that has been amplitude modulated with respect to various amplitude modulation factor. We have learned modulation factor, right? So this model, Deepa, I think you will be able to hear now. Okay, so now we'll look various type of waveform. Okay, these are various type of waveform for different modulation factor. Okay, for waveforms, different waveforms, we can write different waveforms for different values of modulation factor. Modulation factor. Okay, all right. So first thing you can see that this is the original signal. This is the modulating signal, modulating signal. Why we are saying modulating signal? Because this signal will modulate or change the amplitude of the carrier. This is the carrier one. Okay, this is the carrier wave. Okay, this is the carrier wave. When the modulating factor is 0, this is here it is written MA. Actually this is for this MA is same as mu. Okay, same as mu. Modulation factor with respect to amplitude, that's why MA they have written. So MA and mu are the same. So here mu is equal to 0. Excuse me. When this mu is 0, what does that mean? That means, see, mu is actually, just remember, mu is AM by AC, right? So what does this mean? When mu is 0, meaning that at least this cannot be 0. So AC cannot be 0. So this implies if this is 0, mu is 0, this implies that AM is 0. Excuse me. That means amplitude of this amplitude, this is AM. Okay, this is AM, this is 0. When mu is 0, this amplitude is 0. That means the modulated wave will have only the carrier. Only the carrier. So you will get this kind of variation of the modulated wave. I hope you are understanding. So when the mu modulation factor is 0, that means the original signal or message signal has 0 amplitude, and hence the carrier wave will not be modified at all. Its amplitude will be the same as the original carrier wave. So this is the waveform, first waveform with mu is equal to 0. Now if mu is 50%, then what will happen? When mu is 50%, then the maximum amplitude, you can see that we know that mu is 50% means it will be half. If it is half, look, this is a max minus a min divided by a max plus a min. So from here you can show that this is a max, so you can multiply this. So half max plus this. Okay, so let me write it. Half max plus half min a min, and this side a max minus a min. Okay, so what we can write, we can just see that a max will be half a max is equal to, here this will come and add it up, so it will be 3/2 min. Okay, with a minus sign obviously. So if this is maximum, this will be minimum is minus obviously in this sinusoidal variation. So you can say from here, if the percentage mu is this, like mu is 50%, then you know what you get, a max. A max will be 3 times, okay, 3 times a min. See, minimum is actually this particular part. This is the minimum. Okay, this is minimum. Minimum is not this one. This is maximum. This is also maximum. So minimum is this value. This is maximum, minimum value, or we can say somewhat this one. This value is minimum value. Okay, so maximum is 3 times of that. You can see that. So this is the maximum value. So 3 times of this part is actually the maximum value of the amplitude of the modulated carrier wave. Okay, so the modulated carrier wave will be actually called under modulated. This is called under modulated. This waveform is called under modulated. I think you have to sometime remember what is called under modulated, what is called over modulated. This is called under modulated. Okay, this is called under modulated. And what is the condition? The mu has to be 50%, and for that case, what will be the amplitude of the modulated carrier wave? Maximum amplitude will be 3 times the minimum one. Okay, we can write it. We can write just beside. So here the a max is equal to 3 times the a min. Okay, that is what. Okay, this is the maximum value. This is max, a max, and this part, actually we can show you this part is minimum, or maybe this particular value, this is minimum, a min. Okay, and this situation is called, this kind of waveform is called under modulated. Now if you have mu 100%, that means mu is equal to 100%. So you can remember again this a max minus a min divided by see, A max plus A min. So when is it possible to have maximum? When your minimum is zero. Minimum is zero. This implies, so when it is 100%, then this is implying that A min is zero. A min is zero, and that would give you the waveform of this kind. Okay, this is the kind of waveform you get when minimum is zero. Okay, you can see minimum is almost going to be zero here. Okay, almost zero. Okay, minimum is almost zero here. See, this is the minimum. Okay, this is the minimum value, but here minimum is zero. Here, look, this is the minimum, right? This is the, okay, so this is going to be zero. Okay, this is going to be zero, so minimum is zero, and this situation is actually called fully modulated. This is called fully modulated. So carrier wave is fully modulated here. This is called fully modulated. Fully modulated. And here, what is the condition? Condition is A min is zero. Okay, fully modulated. Now look, if the mu is more than 100%, I can take something, some arbitrary value of 150 percentage, 150 percentage, or 1.5. Here ma, suppose 1.5. Okay, so at that condition, what will happen? Uh, a max, a max will be a max will be 2.5 times greater than the carrier frequency, sorry, carrier amplitude, and this is called actually over modulated. This situation is called when the mu is greater than 100 percentage, mu is greater than 100 percentage, then the modulation will be over modulation. Okay, a carrier wave will be over modulated. Okay, this is called, in this case you can see these two are actually, there will be a missing of signal, there will be a missing of signal because of this gap. So this is called over modulated. Over modulated, sorry, modulated. Over modulated. So in case of over modulated, you can see the negative half cycle will be clipped. Clipped means that will be missing. Okay, that will be missing. Then from here actually we can draw some importance of the value of mu. What is the significance? Or see, discussing this within 2 minutes, we'll conclude the class. Conclude the class. So significance of modulation factor. See, we have seen these waveforms, various waveforms. When the mu or modulation factor is very very small, the amount of variation of carrier amplitude is small. Okay, there will be no variation, almost no variation. So this is 50% variation is little bit. Okay, so variation of the carrier wave will be small when, so the modulation factor determines the strength and quality of the transmitted signal. What we have to write? So modulation factor determines the strength and the quality of the amplitude modulated signal. Okay, AM signal. How? When mu is small, when mu is small, the variation of the carrier wave variation of the amplitude of carrier wave amplitude of carrier wave is small, right? And similarly, when the modulation factor is greater than mu, sorry, greater than 1, when mu is greater than 1, there will be missing of negative signal, negative peak of the modulating signal, or we can say there will be discontinuous envelope discontinuous envelope discontinuous envelope which implies missing of signal missing of signal. So this is then when mu is, so mu cannot be greater than 1 in any case when we are transmitting signal from one place to another after modulation. So modulating factor should be always less or equal to 1. Okay, 1 is fully modulated, as we have seen, that is the perfect condition. So modulated wave must not allow the modulation factor to be exceeding unity. Okay, now we'll just discuss just one or two points of the advantages of this amplitude modulated signal. Okay, and then we'll conclude. Just 1 minute more. So advantages are that it is easier to transmit the signal to the receiver end, but just by modulating a low frequency signal you can easily transmit it. What is the second? There are other advantages also, like it requires very simple and cheaper transmitter and receiver and transmitter has to be very simpler one. You need not have very complicated transmitter or receiver. And transmission requires very low frequency band. How much? 0.5 to 20 megahertz. So this much band is required for transmitting low frequency signal by amplitude modulation or after amplitude modulation. And the area in which the amplitude modulated signal can be received is much larger than that of the case of frequency modulation signal. Okay, but there are some disadvantages also. Amplitude modulation suffers from noise, quality of the audio signal will be very poor, and efficiency of amplitude modulation is actually very low. Efficiency is low and it suffers from noise, and quality of the audio signal will be very poor. These are the disadvantages. Okay, so I'll stop it here. Next day we'll try to cover both phase modulation and frequency modulation. Okay, there are three types of modulations. So we had discussed in detail about amplitude modulation of the signal. Now in the next class we'll discuss phase modulation and frequency modulation in detail. Okay, so We'll stop it here for today. So bye for today, Deepa.